Hey, what's up? It's Jake, and this is going to be your introduction to HashiCorp Vault. So, um, what is HashiCorp Vault? Well, it's really just a solution to a secrets management problem. Now, there are some people in today's industry that say that it's not actually secrets management, it's secrets storage, and that's fairly correct, but there are some management aspects to this, and we'll go over that. So what kind of secrets are we managing? So we're talking about authentication, authorization, so username, password, DB creds, API tokens, TLS certificates, stuff like that, and the rotation of all of those secrets. So there's really three areas or levels, problems that Vault solves. So the first level is secret sprawl. Your secrets end up everywhere. It's in plain text in your code, ends up in your headers, it's in your config management, and all of those things eventually end up in some sort of version control system. And then you don't know where someone's getting the information, and if it's out there, whether or not they actually tried to get it. So it's hard to rotate creds like that because when you have sprawl, um, you can't rotate them from some sort of central place. So Vault starts to solve this problem by centralizing all of that and encrypting everything at rest and in transit. It lets you overlay access control over the storage, and it's only accessible via the API, and you can limit that with access control. So like your DB only has access to your DB cred. Your API only has access to the API token if it doesn't need DB access. So then you don't have one place where everybody's can see everything. If you do need to see everything, it does give a little bit more visibility into that because you have a central place for everything. So the second problem it solves is kind of like, well, who are we giving these creds to, right? So applications kind of suck at keeping secrets. So whether you're using Splunk, and I'm not bashing Splunk at all, standard out, monitoring, exception, errors, diagnostics, etc., you could accidentally put any one of your secrets in some sort of file output when you're looking at your monitoring or standard out or something like that. So um, it also tries to solve this problem by using dynamic secrets. So they're short-lived ephemeral creds. You can rotate them on a regular basis. So even if your application leaks, your cred is rotating, which gives a moving target for an attacker. The other unique thing is that each cred is unique to a client. So if you have a bunch of EC2 instances using a credential, each instance could have its own unique credential, so you can trace which machine is compromised. So in the event that you have a compromised machine, you have a better revocation story because you can revoke only isolated access for the machine that got compromised. And even if somebody did have that cred, it does not give them access to every other instance because they're all using unique credentials. The third thing is managing how you protect data at rest in applications. So storing encryption keys you can put in Vault and distribute back out to the application. Apps don't implement cryptography correctly very often, or not, I shouldn't say very often. You can't guarantee it. So you want to get away from storing a key and assuming the app will encrypt it correctly. So Vault will actually let you create named keys, expose a high-level API, and do the cryptography for you. So you can call Vault with the API, and then Vault shields the implementation instead of assuming, and it does the like assuming that the app did it correctly, and then it does the key management, so there's no developer access to it whatsoever. But devs can still use it. It's just abstracted, right? So because the cryptography is implemented correctly, it offloads key management so that you don't have to worry about key lifecycles. In all scenarios, everything's ephemeral. Application accesses creds dynamically with an API variable, which is super handy. So how does it get implemented? Well, it's highly pluggable. So you'll have a central like Vault core, and then it goes through the lifecycle management, but it has auth plugins. So EC2 can use an auth plugin to tie back to the AWS notion of identity access management. You can have a user use LDAP to provide identity to auth. You can have Kubernetes provide identity to auth, stuff like that. So you can take some system you trust, provide proof or trust of identity, and then there is also an audit backend which streams the events to something like Splunk, or you can set up multiple auto logs like Splunk and syslog. Vault stores the data at rest and uses storage backend, so you can put that in RDBMS, console, Google Spanner, etc. Something durable and highly available. So let's go over Vault access to secrets. They use something called secret backing. So if you have like a key value pair, which is static, you can store that in a secret, or you might have a DB plugin with uses secret backing for like RabbitMQ, or you can have AWS S3. And the idea is if you have the secret backing, instead of giving somebody long-lived access with an IAM credential, you can give them short-lived access with a credential that provides temporary access to those resources. Now, all the cloud providers have a version of this that you can do with tokens, but this does centralize all of that so that you can be fully cloud agnostic. You can use your DB creds, your cloud creds, your on-prem creds, your whatever creds you have, API tokens, TLS certificates, it's all in one place. So that's kind of the value of that. It can even broker access to SSH. So at a high level overview, how this is implemented is you allow management of creds against different identity providers. All right, so if you have a core, right, and you have your identity providers over here, maybe it's AWS or Google or whoever, LDAP, and you audit with a trusted log management source. So once it gets authentication, you'll have another layer that's kind of like an audit layer, and that's where you might have Splunk as a trusted source, stuff like that. And then you store data in almost any durable system. I named a few. And then you can extend the type of secrets you want, whether static or dynamic, by adding a new secrets backend or secret backends. Backend? Secrets backends? However you say that word. This is a single instance of Vault. So basically, every single instance of Vault has those three things in common. It has the management of creds, it has an audit, it has a storage layer, and then it has that core all in the middle of it. So in a broader deployment, to provide high availability, you're going to have multiple Vault instances with a shared backend. And that shared backend could even be like a 3-server cluster. So that's highly available. So you have multiple vaults that coordinate with a shared backend, and then they do something called leader election. So they elect the current leader out of all of your vault instances. So you'll have one vault that's basically promoted to leader, and then all the requests that go to vault go to that one, and it manages all of the operations. If your request goes to a different vault, that vault will just forward that to the leader, and the leader will take care of it. So the client sends a request to vault, you talk to the leader, or you're either sent there either way. During a failure, Vault will detect this and automatically promote another node to the leader to have high availability. So it's basically a shared network service that you can communicate via an API over a network. It uses a RESTful JSON API over HTTP, so it's relatively easy to implement. And yeah, that's pretty much it. So that's just a high level kind of like lecture version of the introduction of Vault. So we'll go ahead now and get started with doing some installations.